Merge sort. Merge sort starts by dividing the array or the list that you are given into two halves. Sorting is then done, and then the two halves are merged. So what that means is any list of elements you're given, you look for the middle point, then work with the one half, then do the sorting of that one half, go to the second, do the sorting of that one other half, then towards the end you merge them. That's where now sorting ends, when you are merging two halves that have been sorted. So I have an example here. Using merge sort, arrange the following numbers. The numbers are given from the smallest to the largest. So these numbers are 1, 2, 3, 4, 5, 6, 7. You bring them here. You look for the middle point. These figures are 7, so it's an odd number. So you can either start with the first 3 as one half, then the other 4. In my case, I prefer starting with the first 4, and then what remains is done as the second half. So these first 4, bring them down here. This marks the order of the steps. So step 1 is to divide into two halves. These 4, you again do what? Divide into 2. So these 2 are here, 38 and 27. They are not. Then after that, you again divide into 2. 38 and 27. So you from the beginning of 4 elements into 2 to the point that you have individual elements. To this point that they are now individually arranged, they are not now together, you do the sorting. So when you do the sorting, you have 27 and 27 comes first, then 38 as per these 2. As you can see, this is step 4, step 5, step 6 is to now have the two individual sorted as they should, starting with 27, which is the swap from 38 to what follows. This is step number 6. After these ones are arranged as they should, you then return back to the other 2 up here. These 2 are brought down here. They are still merged. Then get the step where each of them is individual. Then once the 2 are as individual elements, you then do the sorting. So the sorting is done after the elements are individually looked at. Here they are twin. Here they are 4. Here is the whole half. So at the point where you now have individual elements, that's where the sorting happens. This step 8, step 9. Then because this is now 2 halves, you've done the arrangement of these 2 halves. Step 10 should now mean these 2 halves have been arranged as they should, because these 3 will now come here. The 27 comes here. What follows is 38. So you now arrange them as per the 2 halves. That's how the system works. That's at step number 11. So then there's this other half we started. So this one, the one half is sorted as it should. We then have these 3, 9, 82, 10. Divide into 2. First, I start with the 2. This is now individual, to the point where each element is individual. This was left as alone. At this step, it's by itself. These 2 here, they were twin. Down here, they are now individual. So the sorting now happens. What comes first? These ones are arranged as they should. So 9 and 82. And then this individual figure is pushed down. If it had a pair, we would have joined it here, then that would have been the order. But at this level, they should all be individual. If it's only one, it comes down. So the sorting of this single one will happen after these 2 have been sorted. These 2 halves have been sorted. They are brought down. That's when you now include the 10. So at this level, you will be sorting the 3. The 2 pair have 2. The pair has been sorted. And then there's the 10. You now bring them down here. You now have 9. So this half has been sorted well. This other half has been sorted as it should. The last step is to now arrange them as a whole down here, where we now say you are merging. Yes, that's where now the ending of merging sorting happens when it comes to merge sort. We started by dividing into two halves, went down step by step. This middle point case, it has individual elements, and because one is by itself, it had to come down, and then we now have this. Then down here, we now have what? The sorted list. Yes, that's what we mean by merge sort. Bubble sort. Bubble sort works by comparing two data values at a time and swapping them if need be. The comparisons are done in several passes until the array or list is fully sorted. So you are given a list which we are supposed to sort. So it can be a list, another word you will be seeing is array. It's the simplest sort option that works by repeatedly swapping the adjacent elements if they fall in the wrong order. So if they are not following the order that you've been specified, most cases, our case is from smallest to the largest, the two numbers are swapped. This sorting option works with passes. A complete pass means a comparison of two data values and swapping if necessary. So from the first, a complete pass happens when you've compared the first two to the last two. The first two in the list to the last two. Once you get to the last one, we call that a complete pass. Sorting data elements ends when no swapping has happened in a complete pass. You've compared from the first two to the last two and no swapping happened that whole time you were swapping. At every level you swapped from the first two, the two that follows, the two that follows, that way up to the last, and no swapping happened, we say sorting has ended. So I have an example here. You've been told to it's using bubble sort, rearrange the following numbers. The numbers are given by indicating the passes taken by the computer program from the smallest to the largest number. So our first pass, we arrange the numbers as they are given. Then we compare the first two, which is 5 and 1. 5 and 1, which is the largest one. 5 is greater than 1, so you have to swap. So swapping makes the number 1, then 5, then 4, 2. This figure, this arrangement, you bring it here. You then compare 5 and 4. 5 and 4, which is the larger. 5 is the larger, so you again swap. So the number becomes 1, 4, 5, 2, and 8. These figures, you bring them down here. You compare now 5 and 2, which this is our third element and the fourth element. You compare. Another swapping happens to make the number 1, 4, 2, 5, and 8. This arrangement, you bring it down here for the last two, which is now 5 and 8, which is larger. As they are, there is no swapping that is to happen this time around because 5 is smaller than 5 is smaller than 8. Then we go to that marks the end of our first pass because we've compared the first, the second, the third, the fourth to the fifth. We start the second pass. So the figures as they were here, you bring them down here. You compare again 1 and 2, 1 and 4, which is larger. They are arranged as they should, so no swapping happens. 4 and 2, which is larger. 2 comes first, so you swap to make the number this. Bring this list down here. You check which is larger than the other. You again swap. Our case now, no swapping happens between the figures, so the number remains as it is. Then the last thing, you compare 5 and 8. And if there is any swapping that is to happen, our case, no swapping has happened. So in this second pass, the only swapping that has happened is in the second category, the second level, which we were comparing 4 and 2. That is the only part. So the sorting hasn't ended. We start another pass. We say the complete sort happens when all the levels of comparisons, no swapping happened. So our case, we compare we compare 1 and 2, no swapping happens. You again come here, 2 and 4, no swapping happens. Then 4 and 5, no swapping happens. 5 and 8. So this completes that pass. We can comfortably say that no swapping happened, and that marks the end of our sorting. And the answer is now 1, 2, 4, 5, and 8. Thank you. Insertion sort, a simple sorting method like the way you play cards with your hands. Swapping of elements happens in if the adjacent elements are not in a particular order. This is done in rows. A single row contains a single swap. So each time a swapping happens of a particular element, that marks the end of that row. You have to start another fresh row and compare elements that follow that array or that list you're given. Sorting will end when there is no swapping and you've gotten to the last element in the list provided. So when you get to the last element, if you're given 6 elements, once you get the 6th element and no swapping has happened, we now can say the sorting of those elements have ended. So I have an example here using insertion sort. Rearrange the following numbers. So the numbers you've been given are these ones. You're supposed to rearrange them from the smallest to the largest. You start by working with these two. 3 is smaller, so it comes at the beginning. That marks the end of that particular row, because a single swap has happened. You then come to the numbers. The third element, that is 2. 2, where is it supposed to be inserted? It comes at the beginning. That single swap marks the end of that row. We then come to the 4th element, which is 10. 10, as per comparison of 10 and 4, 10 is in the order that it should be, because what is next to it is 4, so no swapping happens. Move to the 5th element, 12 and 10, they are also in the order they should be, so no swapping happens. We then come to the 5th element. 1 is smaller. We should then insert it at the position it should be, which is at the beginning. That swap, individual swap, marks the end of that row. We then come to the element that follows, which is 5. 5 should be inserted between 4 and 10. So it's not a must that each element you're swapping has to come at the beginning. There are cases where the individual element should maybe be inserted in between 2 elements. That's why we call this method sort, insertion sort. So 5 comes between 4 and 10. We then go to the last element, which is 6. 6, by the look of the numbers, it should be inserted between 5 and 10. So you do the insertion. This 6 is the last element. As you can see, we started with 4 and 3. We moved 3. Then came to 2, moved 2. Then didn't move. What follows was 12. 12 also didn't move. What followed was 1. 1 moved to the beginning. We then came to 5. 5 moved between 4 and 10. And then the last element, which is 6. 6 moved to between 5 and 10. When we now come to this row, no swapping happens. So because no swapping has happened, it marks the end of our insertion sort. That marks the end of the insertion sort when no swapping happens at the last element. Selection sort is an option that sorts arrays by repeatedly finding the minimum element from the unsorted part and putting it at the beginning. In every repetition or iteration of this sort, the minimum element from the unsorted sub-array is picked and moved to the sorted sub-array, which is most cases on the left side or at the beginning. This works by comparing arrays and array points from array point 0 to the last, picks the smallest, then array point 1 to the last, picks the smallest, then array point 2 to the last, that way, until you are comparing the last pair. of elements in a given list. This will always maintain two subarrays, one that has already been sorted, which is on the left side, and the one that hasn't been sorted, which is now on the right side. Sorting will end when no swapping has happened and you've gotten to the last pair. You are comparing the last two elements and no swapping has happened. That's where the sorting ends. So I have an example here using selection sort. Rearrange the following numbers. We've been given 14, 33, 27, 10, 35, 19, 42, and 44 from the smallest to the largest. So you arrange them in terms of arrays. These are array 0, array 1, array 2, array 3, array 4, array 5, array 6, array 7. The figures as 8, but because array, when we talk of arrays, we also have to include 0. They are array 0 to 7. The red is indicating to us where the comparison shall start. So we'll compare from array 0 to the last, which is the smallest. The smallest is what is indicated in blue. So this is the smallest. So this 10 comes at the beginning, so they interchange 10 and 14. So you now have 10 here. You've already sorted the 10. So this 10 comes here and 14 has been interchanged. So next row, you will compare 33, which is array 1, to array 7, which is the smallest. The smallest is 14. So 14 moves to where 33 is, and 33 moves to where 14 is. They simply swap. So these two have already been sorted. That's why we were saying you maintain a list which on the left would be having elements that have already been sorted. So 27 is now array 2. So we compare array 2 and array 7, which is the smallest. The smallest is 19. So 19 and 27, they swap. So 19 comes here. So you then come to array 3, because this was 0, 1, 2, 3. So array 3 to the last, which is the smallest, up to here, it's 27. So 27 swaps with 33. So this from 10, 14, 19, and 27, they've been sorted. So they will now compare 35 and to the last, which is the smallest. Between array this and this array 7, it's 33. So these two will interchange. So that 3 comes here, 35 moves. Then you then compare this array point, the last, which is the smallest, it's 42. So 42 and 35, they interchange. And then you will then compare 42 and 44. And because no swapping has happened, because they are arranged in the order they are supposed to, that marks the end of the sorting. So you have the figures down here. So we started by comparing array 0 to the last, array 1 to the last, array 2 to the last that way, array 3 to the last, array 2 that way, until you are on the last 2 and then no swapping happens. That's what we call a selection sort.